Good morning, ladies and gentlemen. It's a real pleasure to be here, and I'm delighted to have been invited, and a particular thank you to Hoike for giving me this opportunity. It was a great pleasure to work with Hoike more than a quarter of a century ago now, and it's a great pleasure to have the opportunity to speak to you today. And I'm going to share with you the experience that the UK is currently having in relation to the emergence of the shale gas industry in the UK, and in particular the public concerns around hydraulic fracturing for shale gas. My organisation, the Environment Agency, is the main environmental regulator in England. We have quite wide responsibilities, and they include the environmental regulation of all kinds of industry, including the onshore oil and gas industry. And I would say that one of the key lessons of our experience, and we are at a very early stage, is the gap between a technical assessment of environmental risk versus the public perception of environmental risk. And in that context, therefore, the importance of public dialogue, building public understanding, and public engagement, which involves listening to and responding to public concerns. But first, to give you a little bit of context, gas is a very important fuel in the UK's energy system. It currently supplies about a third of the UK's energy needs, and those needs include heat as well as electricity generation in both homes and in industry. And gas will continue to be an important part of the UK's energy system, including in circumstances where the UK meets its climate change obligations. The UK has a legally binding commitment to reduce its greenhouse gas emissions by at least 80% from the 1990 level by 2050 under our Climate Change Act. And this graph shows you the central scenario from the UK's advisor on climate change, the Committee on Climate Change, as to how gas use might change. So we expect that it should fall, but it will still remain a significant part of the energy system, even out to the middle of this century. The UK has a major oil and gas industry, but the very largest part of that is offshore in the North Sea. We have a small onshore industry, and that is beginning to grow. The issue for the UK is that production of oil and gas in the North Sea is now declining, and the UK is very dependent on imports of gas. About half of the UK's gas is imported, and that proportion is growing as North Sea gas production declines. And that is why the UK government is interested in understanding whether the UK can exploit its onshore domestic shale gas reserves. And it seems that the UK has large deposits of shale gas, particularly in the Bowland Shale, which is in the north of England. This particular diagram shows you the areas of England and Wales and Scotland that are licensed for oil and gas exploration and production by the Oil and Gas Authority. But at the moment, the onshore industry is small, only a few hundred wells, and although it is growing, it is not yet a significant part of the UK's energy system, and at the moment it's a conventional industry producing oil and gas from conventional reservoirs. We do not yet have a shale gas industry. We are at a very early stage indeed. And in fact, only one well in the UK has been hydraulically fractured for shale gas. And that was in Lancashire in 2011. Unfortunately, that operation hit a geological fault and induced some earth tremors. And as a consequence of that, the operation was suspended, a scientific investigation was undertaken, and although in principle it is now possible to undertake high-volume hydraulic fracturing again, in practice no site has yet got planning permission to do so, and that's because of the public controversy and public concern around the emergence of this industry and this particular technique. This diagram just gives you the final piece of context, which is a picture of how the regulatory system operates in England, and similar systems operate in Scotland, Wales and Northern Ireland, but they're all a bit different. And as you can see, it looks a bit complex, but in essence, there are a number of regulators and each has a different part to play. So if you want to undertake hydraulic fracturing for shale gas as a company, you need a license from the Oil and Gas Authority, which is effectively the economic regulator charged with maximising economic recovery of the UK's oil and gas reserves. You need planning permission from the local mineral planning authority, which is usually the county council. You need the relevant permits from the Environment Agency for environmental protection, and you need to be able to demonstrate to the Health and Safety Executive that the operation will be conducted in a way that is safe for the workforce and for the community around the location. And unless and until all of those things are in place, the operation cannot proceed. So that's a bit of context for you. Because of the controversy surrounding hydraulic fracturing, and particularly people's perception of the environmental problems that had been caused in the United States by the shale gas industry, it was important to us as the environmental regulator that we had a very good understanding of the environmental risks involved in exploring for and potentially extracting large volumes of shale gas. So we undertook our own environmental risk assessment of all of the industrial processes that would be involved in exploring for and extracting shale gas using hydraulic fracturing. And that environmental risk assessment was based on a mixture of our experience of regulating the onshore oil and gas industry for many years, on a review of the scientific literature, and indeed, in addition to those two things, some professional judgment from our environmental and regulatory experts. And the next three slides summarize the findings from that environmental risk assessment. One of the things that this risk assessment showed was that, in fact, one of the key things it showed was that the main environmental risks are at the surface or to do with the construction of the well, rather than, in most circumstances, the hydraulic fracturing process itself. So at the surface, some of the key risks are in relation to the potential for leaks and spillages of chemicals and the handling and management of waste. Hydraulic fracturing produces large volumes, for example, of waste fracking fluid. It's quite important to look at the depth scale on the right-hand side of each of these graphs. Another key risk, as I was mentioning, is that it's very important to protect the environment that the well is properly constructed. In particular, that it is properly cased with steel and that there is proper cementing between the concentric cylinders of steel casing. In the UK, there need to be at least 3 concentric cylinders of steel casing surrounding the outside of the well through all of the layers where there is significant groundwater. But it's important that in between those layers of casing that the concrete seal is done properly, because if it isn't, that creates a pathway for gaseous and other pollutants to leak out of the well, potentially into groundwater. And in actual fact, all of the evidence suggests that where there have been problems with shale gas operations in the United States of America, it has been because of poor construction of the well or poor practice at the surface. Very, very rare for hydraulic fracturing itself to be the cause of the problem. And that is because in most geological circumstances, the high-volume hydraulic fracturing is taking place at great depth. In the kinds of geology that we are looking at in the north of England, the hydraulic fracturing would take place at a depth of more than a mile, 2 to 3 kilometres below the surface. And because of the controls that are placed on hydraulic fracturing, the possibility that the hydraulic fractures themselves will extend far enough to create a pathway for pollution to reach overlying groundwaters is extremely low. Now, of course, that is very different from the public perceptions of risk. The public perception of risk is that it is fracking that is the key issue, rather than the processes that occur at the surface, and in particular the management of wastes and the controls that will prevent leaks from the well itself. Having made an assessment of the environmental risks, we then did a careful check to see whether those risks could be controlled and whether we had the necessary regulatory powers to ensure that those risks are controlled. And our assessment is that we do have the necessary controls, and those risks can be mitigated if the right conditions are placed on the operation. And we have the necessary controls largely thanks to a set of powerful European Union environmental directives. And they include the Water Framework Directive, the Groundwater Daughter Directive, the Mining Waste Directive, and the Industrial Emissions Directive, amongst others. And in England, those directives are implemented by the Environment Agency through the environmental permitting regulations and the Water Resources Act. And between them, those regulations overseen by these environmental directives give us the powers that we need to ensure that the operations are conducted in a way that protects people and the environment. And now we're at a very early stage of the development of the industry, as I was describing, and we will need to keep that assessment under review as the industry develops. But that is certainly our view at the present time. And I just wanted to highlight to you some of the features of our regulations that enable us to ensure that the environment is protected. So, for example, in relation to water, we will not allow the drilling of oil and gas wells, whether conventional or unconventional, in the areas that are most important sources of drinking water, so-called source protection zones 1. We simply don't allow drilling in those areas. Everywhere else, we require a site-specific hydrogeological risk assessment so that we can have a good understanding of the risks at that particular location. And on the basis of that assessment, we will decide whether the operation can proceed or not, and what conditions should be attached to that operation through our environmental permits, which are legally enforceable. In relation to the use of chemicals, which is of course extremely controversial, because in the United States a large number of chemicals have been used in hydraulic fracturing, some of which are highly carcinogenic or are liable to cause endocrine disruption and interference with gender. Our system requires that each chemical that an operator proposes to use is individually assessed, and we have a policy that we will not allow the use of chemicals that are hazardous to groundwater in circumstances where they may enter groundwater. So we don't allow the use of hazardous chemicals in hydraulic fracturing fluid. And our system also requires public disclosure of the chemicals that are used, so it's very transparent. Our regulation covers the management of all the waste materials that are produced by oil and gas production, and that includes the solid wastes, for example, the drill cuttings, the liquid wastes, for example, waste fracking fluid, and the gaseous wastes, because of course if you don't actually use the natural gas, it becomes an extractive waste under the terms of the mining waste directive. And our regulatory system requires the operator to produce a mining waste plan that shows that they are using the best available techniques, and that plan has to be approved by the Environment Agency as part of the environmental permitting. So for example, we would not, as is allowed in some parts of the United States, allow the storage of waste fracking fluid in open pits or open tanks. We require waste fracking fluid to be stored in seal tanks and taken off-site for disposal at an appropriately licensed wastewater treatment facility. In relation to the management of the potential for waste gases, we do not allow the venting of gas. We don't consider that to be best available technique. We expect all of the gas to be captured, including the gas that comes back to the surface with the waste fracking fluids. At the exploratory stage, we think that flaring is an acceptable way of disposing of the gas, provided it is done to high standards and in an enclosed flare rather than an open flare. At the production stage, we would require what is called green completions or reduced emissions completions, which means that the waste gases have to be captured and put to productive use, either piped off-site and used off-site in electricity generation or for heat production, or used on-site for electricity generation. And our system of regulation also requires the operator to undertake environmental monitoring of groundwater and of air, and to report the results of their monitoring to us. And we require that monitoring to take place before the operation begins, so baseline monitoring, so we can understand the state of the environment before the operation began. Then monitoring during the operation, so that we can see if there is any change in the state of the environment and require action if we spot that there is. And then we can also and do require monitoring even beyond the decommissioning of the well until such time as we are satisfied that there is no significant ongoing risk to the environment. And we continue to try and learn as we go along, and we are continuing to undertake scientific projects to improve our understanding of the oil and gas industry and to improve our understanding of the potential environmental impacts. So, for example, we have been working with the British Geological Survey to assess the levels of methane in groundwater across the country to provide us with a baseline assessment so that we would be able to detect whether there has been any change as a result of the development of this industry in the future. And that's something that wasn't done in the United States, and it's one of the reasons why it's often quite hard to tell whether methane in groundwater was already there or is as a result of the industry. And as I mentioned at the beginning, there's quite a gap between our technical assessment of risk versus public understanding of the risks. There is a great deal of concern about the emergence of hydraulic fracturing as a potential industrial technique in the UK. So one of the things that we do when we receive a permit application from an operator is we consult on that permit application with the local community. We engage with the local community and talk to them and listen to their concerns, and we do that in close cooperation with the local minerals planning authorities and the other regulators. And in fact, in the last few months, we have also developed a video and a leaflet which we can use in public meetings to explain our role and how we take steps to protect the environment. And the government has given us some extra money to do that this year. So just in conclusion, we believe that we have made a thorough assessment of the risks of this emerging industry and that we have the necessary controls to ensure that it can develop in a way that is protective of both people and the environment. But we are at a very early stage. We have now granted environmental permits for 2 sites in Lancashire, but they have yet to get planning permission, so the operations are not yet underway. We are currently in the final stages of determining permits for a 3rd site in Yorkshire from a different company called Third Energy, and we expect more applications to come through. But we are a learning organisation and we will reassess our regulatory approach as the industry develops. Thank you for listening.